Hello everyone, can you guys hear me? Yeah, cool. Welcome back everyone. I hope you guys are doing good. We have 24 people in the class. I am assuming that less people will turn out today because it's a Saturday. Uh, but okay, we will just take maybe 5 minutes to revise what we did in the last class. We are going to build very much on top of that last class itself. And let me just take 5 minutes to revise all that and I'm hoping that more people will join in. Did you guys, by the way, revise the last class yourself? Did you guys revise it? We discussed so many things in the last class. I hope you guys revise those concepts. Anybody who's feeling as if they are not understanding what we are discussing in high level design these days? The last class was primarily about storage, and today's class is also going to be about storage. Okay, and most likely we're going to have one more class after today's class, which also deals exclusively with storage. Okay, cool. So let me just summarize what we did in the last class. So we were discussing that how do we enable the support for multiple simultaneous queries which are trying to access the same data. Do you guys remember that? We were discussing about SQL systems to begin with, and we were seeing that how you can utilize a database and what kind of a isolation level would you require in a transaction, which would give you support for different kinds of use cases that you have. Okay, we discussed about different isolation levels, and in fact before we discussed the isolation levels, we discussed that transactions come with properties called as asset properties. Do you guys remember that? So atomicity, consistency, isolation, and durability. So we discussed what is atomicity, we discussed what is consistency in terms of databases, we discussed what was durability, and the major part of our discussion was isolation. Okay, cool. We discussed several isolation levels. The first isolation level that we would have discussed would have been read uncommitted. Do you guys remember that? So read uncommitted basically was that you do not give any kind of a commitment. It's as if key. So okay, one more thing. So you realized. So I would just give you that diagram once again, which also is very very important. So look at this diagram. So basically, any transaction would be at any one of these states. Do you guys remember that? So the very first, the moment the transaction begins, it goes to this active state. Now it will be keeping on. What is a transaction basically? It's just a way of combining multiple SQL statements into one logical box. Do you guys understand that? What is a transaction basically? A transaction is just basically abstracting out and collating a group of SQL statements together, right? And now whenever a transaction is in active state, it will keep on executing those statements one by one. The very first statement it executes, it now moves to this partially committed state, right? It will remain in this state unless and until it is executing all these statements one by one successfully. The moment any one of those statements fail, you actually move from this partially committed state and come to the failed state. Does it make sense? And now from the partially committed, if you keep on executing all the statements and everything executes, you move to the committed state. And once you commit, then you can end, right? So we were discussing about the first thing, which is read uncommitted, which sort of says that there is no guarantee that I'm giving you. You can essentially, any transaction can actually read data which is uncommitted as well. Does that make sense? So basically the data that you wrote after a partially committed state, though that kind of a data can also be read by other transactions. Does that make sense to everybody? Is everybody on the same page in the class? I hope we are, right? So we discussed this. We then saw an example where this would create a lot of issues and our users would not be happy, or maybe the kind of application that we want to build, we would not be able to build. Of course, I'm not saying that none of the applications in this world can use read uncommitted. And you also understand, I must have told you that this thing in the last class, and I have actually written it here. So whenever you are moving down these isolation levels, whenever you are increasing the isolation level, that is, you are making sure your very transactions should remain as isolated as possible, you guys would realize that you are making your system slower and slower. Does that make sense? You are getting more guarantees out of the database, out of the box, but at the same time, your system is becoming slower and slower. Does that make sense to everybody? Right. So I am not saying that read uncommitted, no database in this world would be using it. but very few where the where the data sanity is not required at all. Only those kind of storage, in those kind of storage you would be using the read uncommitted isolation level. Then we move to the read committed, which gave you a couple of guarantees. The guarantees were that any data that you will read will only be committed, and you cannot read uncommitted data. So what does that mean? So you can only read data from a transaction. So okay, what does it mean? So the data that you're reading only changes because of some other transaction once that transaction has committed. Does that make sense? Is it a good way to put it? The data that you're reading from any transaction reflects effect of any other transaction only when that transaction has been committed. Makes sense. So this was the first guarantee. The second was that it will not overwrite any uncommitted data. I hope it makes sense. Cool. And now the third isolation level was write log is also considered in this, right? Okay, Nikhil. So whenever we are discussing about locks, Nikhil, lock is at a level which is much more at a fundamental level. Okay, we were discussing things at a much broader level. I did tell you that how this actually gets implemented. While implementing this, of course, yes, you are going to use read locks and write locks. But even if you do not know about read locks and write locks, and if you know about these abstract concepts, you can become a developer and you can actually use these concepts to build a system. Does that make sense? These read logs and write logs are primarily about how to implement this, right? How would a database, if somebody is designing a database, how would they have implemented this kind of isolation level? So we went a step ahead and discussed that as well. But I hope nothing, you do not get confused here. Okay. Now Bishali says, what was the issue with read committed? Can we recap that too? Bishali, you should have done that yourself. I am just repeating a few things so that I hope everybody's on the same page. But if you would want me to repeat every small thing, then it would be very, very difficult, right? So let's look at this diagram, right? So let's not go into full detail. Try to understand when you are reading something which is just, okay. Yeah, so we exactly, Uzair is absolutely right. So we took this example where there was a husband and wife who were trying to access two different accounts. They both were joint holders of both the accounts. And then what happened? Let's say a husband is making a query, just making a transaction in which he is getting the balance of both the accounts. Okay, and now the wife is also making a transaction in which she is transferring some money from one particular account to some other particular account. Okay, and then we drew this diagram. We saw that the transaction that the husband is doing, let's assume, starts at this time t1, and the transaction that the wife is doing, let's assume this starts at time t2. Okay, and the transaction that husband is doing, by some random chance something bad happened and that transaction took longer than expected. Okay, so when I say longer than expected, that does not mean that any database is giving you any kind of a guarantee how much time is going to take, right? It's totally random. I hope you guys agree to that. Does it make sense? So a transaction which started before some other transaction can very well end after that transaction as well. There is no sort of a guarantee which tells you that a transaction which started before should end before as well. I hope everybody's on the same page, right? Because we are allowing for multiple things to happen at the same time, and we are not worrying about what happens at what instant, right? Makes sense. Now, the transaction that the husband was doing was to fetch the data. He fetched some data before the other transaction started. So whatever he was fetching about the account one would have not reflected the effect of the transaction that the wife was doing. Does it make sense? Because it did not even start. So he just got the data from a previous state. And before he could get the data for the other account, the transaction of his wife started and committed as well. The moment the wife's transaction got committed, and when after that, if he's reading something, his read will reflect the changes that some other transaction made, and now those two things will not be consistent with each other. Does that make sense to everybody in the class? I see that Vishali, it makes sense to you. Does that make sense to everybody else in the class as well? Makes sense. Cool. So we discussed that this also is not going to, but this works fine. But the problem is it may give you inconsistent states. And if you are dealing with some things like where inconsistent states can cause a lot of problems, then you should not be doing this kind of a isolation level. The third that we discussed was basically snapshot isolation level. Here we tried to just solve the problem that we saw in the read committed wala thing. We said, okay, the data may not be the most recent, but let's just make sure that the data in any one particular transaction is at least consistent amongst itself. Does that make sense to what I'm just saying? Snapshot just said that no matter whenever, at whatever time a particular transaction is reading data, it will always read the data that was there before that transaction started. Does that make sense to everybody? So that no matter how long a transaction gets, at least in the transaction, you are getting the same consistent data. Does that make sense? It may not be the latest data. Of course, maybe your wife has done some transaction, but you are still see, maybe let's say your wife went ahead, or let's say wife is not the one who is just making some random purchases. Let's assume the husband is the one who's making some random purchases, right? So let's say the husband is out of his mind and he just goes and buys, let's say, what would he buy? Let's say he buys some car. Okay, I am not able to come up with a more fancier example. Let's say he just buys some car, right? And without asking his wife. His wife is just doing a transaction, figuring out how much money their accounts have, and let's say planning for their children's future. And she is very happy that yes, there is money, but maybe the husband made some random purchase out there, and now the transaction that the wife would have done may not be reflecting the latest state, right? May not be reflecting that the husband has made some silly mistake, but still at least the data that she would be getting would at least be uh, consistent. Does that make sense to everybody? Right, consistent amongst the transaction. I hope it makes sense. What do I mean by consistent here? Then I discussed that how these kind of snapshots are actually maintained. For that, we went to MVCC. I'm not going to repeat it. I hope you guys can do it yourself. Now, we ended our class discussing a specific example in uh, which was actually building to formulate the requirement of another isolation level. Okay, so is everybody with me till this point in time? Did you guys able to revise everything that we discussed in the last class? Are we all on the same page now? We all are on the same page, right? Cool. The last example that we did in the last class was, let's assume you are vying for competing resources. Let's assume you are building an application where you're competing for some resources. What does that mean? That basically means that there is a set of resources and everybody around is competing for those resources. Like let's say booking a railway ticket, like let's say booking a book my show pay, booking a ticket, or let's say booking a flight ticket, or let's say a very simple example that we took was primarily around he there is a hospital. Every hospital has the hospital has different shifts, and every doctor is, let's assume, marked present for every shift. Okay, it's a tough world out there for the doctors, right? They actually spend a lot of time doing a lot of hard work for the society, right? So we must respect all the doctors that you see around, right? Cool. So let's assume for every shift every doctor is marked present initially, and the hospital has a rule that at any given shift there must be at least one person who is present. Does that make sense to everybody? And now if any doctor wants to take a leave for any particular shift, he or she will have to apply for that leave beforehand. And the moment somebody has trying to get a leave, the system needs to check whether there are at least one other person who is still active for that shift. If there is some other person active, then you can grant that leave, otherwise you cannot. Now you see that we are competing for resources here. Does that make sense to everybody? The resources are leaf, and we are real time competing for resources. And our database should also reflect, it should also be that isolated that it should be able to handle that. So what did we do? We actually wrote a SQL query, not a query. Basically, we wrote a combination of queries. So we said that first of all, what would you do at the beginning of your transaction? You will figure out कि अच्छा बताओ यार इस shift में how many people are on call. So you'll just select the count star of all the people who were on call at that particular shift. This is the first statement that you do. The second statement that you do is check if the number of people who are on call is greater than equal to 2. Then you actually say कि भाई okay, this particular doctor can take a leave, and you will update the leave thing for this doctor. Does that make sense? Does that make sense to everybody? Now, assuming that we were using a snapshot system, let's say, assuming that we were using a snapshot system, anybody of you would be able to volunteer and help me draw that diagram, which will show that snapshot is not going to be sufficient here. And I'm giving that you outrightly that snapshot is not going to be sufficient here. Would anybody in the class, or okay, let me just do it myself. So the point here is what happened. Okay, so what happened if when the first doctor was trying to take a leave, when he or she actually got the number of people who were, let's say, on call at that point in time. Let's say those were four. Okay, there were four people who were on call at that particular instant, and then you are writing, then let's say at this at some time, matlab ki, because every time you are going to read the data which was there before your transaction started, right? Does that make sense? So now what will happen, you will just read the data which tells you four doctors, or let's assume only two doctors are there, and some other transaction also started, that will transaction will also read from the same resource and figure out that two of them are available. Both of them will check this condition. Will the condition pass for both of them, folks? Will the condition pass for both of them? I will want everybody in the class to reply. Would the condition pass for both of them? It will, right? Cool. The moment the condition passes for both of them are going and updating a data point. Does that make sense? Both of them are going and updating a data point. What they are doing, they are actually making themselves unavailable for the call for that particular slot. Does that make sense? So they are saying कि भाई मेरे को mark कर दो कि मैं तो free हूँ. But the problem क्या हो गई है कि both of them marked it and now there are zero doctors available. Does that make sense to everybody? And do you guys also appreciate a very interesting thing here? The very interesting thing that you guys should be able to appreciate is कि भाई we are in both the different transactions, we are updating different data. Does that make sense? We are updating different data in both the transactions. In transaction one, the doctor A is trying to update his row. In transaction B, doctor B is trying to update his row. Does that make sense? They are not updating the same data. But even if they are updating different data, the outcome changes. Does that make sense to everybody? I am not very sure. So I hope the outcome makes sense to everybody, that here the problem is that you would not only worry about, it's not only sufficient to worry about that you take a write log on one piece of data. Even if the first person was taking a write log on his data, and even if the second person was taking a write log on his particular row, the problem would still exist. Does that make sense? So now for this, and because we want to discuss a lot of things going forward, I would just tell you that this kind of a isolation level is called as serializable. Okay, what is it? The isolation level which actually the data point can't be same in this example, isn't it? Yeah, makes sense to that. So what we are going to do, we are going to discuss the last isolation level that we want to discuss, that is called as serializable. Now what does serializable mean? This is in fact the highest form of isolation. And what guarantees does it give you? The guarantees that it gives you is that the transactions would only be implemented in an order which is serializable. Okay, what does that mean? It means, okay, let me just write it and then let me explain it. The transactions would occur only in the order which can be serializable. What does that mean? Okay, so Manish says that the transactions will not overlap. That's wrong. Okay, if anybody feels that this statement means that no transactions will overlap, that's completely wrong. Do you guys appreciate why that's wrong? If I'm giving you a guarantee that no two transactions can overlap, what does that mean? That means I'm building a very trivial system. I'm just saying that there is some sort of a queue and the transactions will happen one by one. Does that make sense? And is it a good thing to do? Essentially, you are taking a write and a read lock on on the entire database and saying कि भाई ठीक है ये करके चला लो. ठीक है? That's not. I hope everybody in the class appreciates that you cannot just say that no two transactions will ever overlap, because that sort of totally defeats the purpose of why we discussed all this thing, right? So now the point here is that the transactions will occur only in the order which is serializable. What does that mean? That basically means the execution of operations would be such as if they would look like they were executing serially. What does that mean? कि भाई concurrently only you will still be executing operations concurrently. Concurrent execution in such a way that the result will be same if they occurred serially. What does that mean? It means कि the execution का only that order will be followed, which will give you the same result as that of if they were being run serially. Does that make sense? It is a big guarantee that you are giving. Okay. And does it also make sense that this guarantee is as good as things actually if they were running serially? But the only thing that we have removed is कि भाई अगर कोई ऐसी transactions हैं कि even if they were running concurrently, but still they would not affect each other's result, so you can run them parallelly. Does that make sense? And in a real life scenario, you are bound to see a lot of such transactions happening, which are sort of working totally on unrelated things. And even if you were running them parallelly, they would give you the same result. Let me just give you one example here. The example can be, let's assume there is a transaction one and there is a transaction two. Let's assume the transaction one that you have has the sequence of, let's say, operations. Okay. So the operation one was C1, operation two was C2. Okay. Let's say for transaction two, the operations were C3 and C4. Okay. Now let's say if, let's say, there are different, do you understand that there would be different, let's assume only these two transactions were there. Do you understand for these fundamental basic operations, unitary operations, there would be different orders in which these operations can be executed? Let's assume this is the time axis. Can you guys understand that there can be different operations in which, in the order of which these operations can be performed? These are fundamental basic operations. Can somebody tell me number of ways of these operations that can be performed? Can someone tell me? Two ways? दो ही वे हैं क्या यार? चार fundamental operation है. There are four fundamental operations. How many ways do you see? Four factorial, right? So basically one would be C1 पहले चला, फिर C2 चला, फिर C3 चला, फिर C4 चला. Other one would be C1 चला पहले, फिर भाई मन कर गया C2 चल जाएगा, फिर चलेगा C3 चल जाएगा, C4 चलेगा. Four factorial नहीं होंगे क्योंकि point ये है कि C2 C1 से पहले नहीं चलेगा. Does that make sense? C1 will never occur before C2. So the point is you will just do 4 factorial, which will give you all the permutations, and then you can primarily say कि C1 C2 आपस में वो नहीं होगा, divide by 2 factorial, C3 C4 आपस में नहीं होगा, divide by 2 factorial. Does it make sense? So 4 factorial divide by 2 factorial, 2 factorial. And this number seems very small because it's only four unitary operations. But if there were so many different operations, you would see that this number would grow very quickly. Sukanya, you are right. Sukanya, you're absolutely right. Does that make sense to everybody? Are you guys with me? Are you guys not with me? Okay, you guys are with me, right? So now, अगर serializable नहीं होता, if this isolation level was not serializable, any one of these sequences could have been performed equally likely. Does that make sense? There is no preference for any such sequence over any other sequence, right? But the moment you set the isolation level of your DB as serializable, only those subset of operations, of order of operations, can occur, which would give you the same result if you did that thing serially. What does that mean? So let's assume C1, C3, C2, C4. If you run in this one, because C1 pehle aaya, C2 aaya, C3, C4. If you did this way, and whatever answer that you got, if this answer is the same, if you were doing it serially, which was C1, सबसे पहले पहली transaction 1 चला दो, C1 चला, C2 चला, फिर C3 चला, C4 चला. If the answer of these two things are same, only then this order can occur. Does that make sense to everybody? Does that make sense to everybody? Waiting for more people to reply. So serializable gives you the promise that whatever order in which I'm going to run my operations is going to be the order which is going to give you the same result as if they were running serially. They are not running serially. Never assume they are running serially. They're still running concurrently, but you would not allow any operation to occur if they would change the result. Now a very good question arises, ki how would you figure out ki whether which particular sequence of operations is going to give you the same result? Does that make sense? Isn't that a very interesting question to answer? Okay. Okay. But we are not going to discuss that in today's class because that would take a lot of time. Okay, so if you guys want, you can read it up. If you want, maybe if most of you want, I can maybe do it in one of the later classes, somewhere down the line, but not today. Does that make sense? And this from interviews perspective, this is not important. But knowing how this happens is not important. Knowing that this kind of isolation exists is important. But Uzair has a question here. Uzair says, but we can't guarantee that in every scenario, isn't it? Okay, so okay, a very good question from Uzair. Uzair is saying, can there be two transactions in which if you take any random ordering, it would not give the same result as a serially executed one? Folks, did you realize what Uzair is asking? Uzair is asking, ki, bhai, can there be any true transactions in which there is no random ordering, which would give you the same result as if they were executed serially? But just try to appreciate that if they were executed serially also, that's also one of those orderings, right? Does that make sense? Even if they occurred C1, C2, C3, C4, that's also one of the possible orderings. And I am just giving you the guarantee that I'm only going to choose any one of the orderings which gives you the same result as if they were occurring serially, which would essentially mean that I am actually going to run them serially if there is no other order. Does that make sense to everybody? Does that make sense to everybody? Okay. Am I going too fast today? Are you guys feeling bored today? Because I do not see so many replies coming. You guys appreciate what we are discussing, right? Cool. Cool. We discussed this. Now we have to discuss about some problems, basically not some problems, some definitions. And looking at those definitions, we would now want to characterize these four isolation levels and see what isolation level gives me what kind of a guarantee. Does that make sense? Cool. Before that, let me just make one comment here. Okay, that comment is basically that, and we discussed that a bit in the last class as well. That comment is about ki yaar, I have taught you some basic concepts, right? I have given you some concepts, and to make you guys understand those concepts, I have used some definitions. Does that make sense? I've used a definition which is called serializable. I used the definition which is called read committed, read uncommitted, snapshot. Now, the only reason why I took those definitions was to get the concept across. Okay? I have told you the entire concept which is going to help you in any interview. Okay? But just one thing that you should keep in mind, the definitions, the exact definitions change DB to DB. Does that make sense? So saying that a MySQL DB is serializable versus saying, let's say, a Postgres SQL is serializable may not essentially mean that both of them give you the same guarantees. Does that make sense? Folks, does it make sense? Okay, so let me just give you one example. So the snapshot that we discussed in MySQL, that is actually called as repeatable reads. Does that make sense? So the snapshot thing that we discussed in the domain of MySQL database is called as repeatable reads, right? And I cannot just stop anybody from calling them repeatable reads, right? So the definition can vary from DB to DB, but the concepts, the fundamental concepts remain the same. Cool. Now let's actually discuss the problems, the phenomena that are there, which will allow us to categorize these four things for us. Okay. So the first phenomena is called as a dirty read. Okay. Let me give you the definition of a dirty read, and then we will explain what is a dirty read. Okay. The dirty read says when a transaction reads a data that has not been committed yet. A transaction reading a data which is not committed yet. Is the definition clear? Do I need to explain it? I need not, right? This is very, very simple. Right. Exactly, Sankalp. We are going to come to that. So this is the first phenomena. Let me discuss the second phenomena. The second phenomena is called as non-repeatable read. Okay. Abort is also necessary. I did not get what you are saying, Lokesh. Do you want me to unmute you, Lokesh? Abort is also necessary. Dirty read problem. Okay. The dirty read problem simply says ki yaar, you are reading something which is not committed yet. Okay. So are you saying that if this will only create a problem if the abort of one transaction happened? Is this what you're saying? Okay. So Lokesh, that's not true. That's not true. By definition, it simply means that you are reading something that has not been uncommitted. That has not been committed. Okay. Will it cause a problem? Not cause a problem? That's for different scenarios. You can look at different scenarios to realize whether it causes a problem or not. Does it make sense? Cool. The second phenomena that we want to discuss was non-repeatable read. What does that mean? That means that when you are reading from a transaction reads the same row twice and gets different value at different instances. Okay. So basically, let's say a transaction is performing the same select statement, reading the reading the same data, but get different results in different times of that same transaction. Does that make sense? People, you will have to reply. See, I am actually taking class on Saturday as well, giving everything that I have. Please reply, right? So, transaction reading the same data, but getting different responses, different values at at different times of the transaction. Okay? At different times of transaction. Cool. So we will see where it is a problem, where it is not a problem. The third is what is called as phantom reads. Now, what is phantom reads? Phantom reads is when two same queries executed, but the rows retrieved by them are different. Okay, so let's say there are two same queries which are executing, which are running. Let's assume, and the data that they are reading is different. So what will happen? I will just give an example. So suppose the transaction one, there is one transaction which retrieves some rows. Okay, there are some rows. Let's them call them rows ka set A. So there are some set of rows A, and the transaction one is retrieving data from those rows. Okay. Now transaction two generates some new rows which sort of fit that particular definition of A. What does that mean? I was saying, let's assume there is a set of rows A. ये set कैसे आया? There is some common condition that these rows are fulfilling. Does that make sense? So let's assume कि you are running a transaction in which you are getting all the males all the male students in your academy. Okay. Now you are running you have a set of rows which have some common condition, right? And now let's assume there is a transaction two also which is running and is generating some rows, and some of the rows it generates actually belong to this set, because transaction two is generating some rows. Some of them will not belong to this set, but some of these will belong to this set. Let's say it is generating some rows which some of them happen to be males. Does that make sense? Right. So now what will happen? If the transaction T1 re-executes the statement that were reading the same condition, it will get a different set. Does it make sense? And I'm talking about the same transaction. If in the same transaction I'm reading the set again on the same condition, I'm running a SQL query on the same condition, I will get maybe some more rows or maybe some less rows as well. Maybe transaction 2 was deleting some rows. Does that make sense, people? Does that make sense? So that is why the name phantom reads. What is meant by phantom reads? Ki bhai, you read something that never existed. To you now it seems कि यार तो कभी था ही नहीं, पहले कैसे आ गया था, right? But that is not only for deletion. Addition maybe sort of remains as it is. Okay, cool. Now let's actually draw that draw this for everything that we discussed. Let's say actually we would go back to everything and write whether these three things are possible there or not. Okay, so let's first of all go to the first thing that we saw, which was read uncommitted. So you guys tell me, read uncommitted may can you see the problem of dirty reads? What is dirty reads? Well, you can see the problem of dirty reads, right? Okay, so rather than doing this, let me go to that page where we have written the definition so that all of you remember the definition, and now we can figure out. So dirty reads, batao. Will dirty reads happen in read uncommitted? Yes, dirty reads will happen in read uncommitted. Will dirty reads happen in read committed? Basically, will you be able to read something which is not committed in read committed? No, you cannot. And in any of the further rounds, you cannot do it. Okay, so this is only possible read uncommitted. Now let's come to non-repeatable reads. That is, you read something, the next time you are going to read, you are not sure if you are going to get the same thing. So you tell me, can this occur in read uncommitted? Can this occur in read uncommitted? Yes, this can occur in read uncommitted. Can this occur in read committed? Yes, this can. We discussed that. Exactly the same example that we discussed. So this can occur in read committed as well. Can this occur in, let's say, snapshots? It cannot, right? It cannot, right? Because I'm snapshot basically means in MySQL I told that कि snapshot वाले मतलब को बोलते हैं repeatable reads, right? So This is not possible in snapshots. Now let's come to phantom reads. So you tell me, read uncommitted में for sure. So read uncommitted phantom reads कर सकते हैं. No. So Archit is saying no. Is it yes, right? Phantom reads can occur in read uncommitted. In read uncommitted, all of these three phenomenon can occur, right? In read committed, can phantom reads occur? Yes, right? Can it occur in snapshot? Yes, right? Can it occur in serializable? Can it occur in serializable? No. Okay. So Sukanya is asking how snapshot. Would anybody in the class want to explain that to Sukanya? How in snapshots can phantom reads occur? So the point here is, Sukanya, that you are not stopping somebody else to add or remove some rows in the criteria that we were doing. So let's look at the doctor wala example. Okay? So you are not stopping any other transaction from saying ki bhai, I will write something and say ki bhai, number of doctors available are reduced. Does that make sense? Does that make sense? Suganya, does that make sense? So you can read something which in your transaction never actually existed. वो बीच में खत्म हो गया था और तुम आगे जाके भी अगर फिर से पढ़ रही हो वही सेम चीज, reading the same thing, you may actually have something which did not exist, right? Makes sense. So phantom reads. So we have discussed this very exhaustively, I would say. Let's now move to the next topic in storage. Is everybody happy with all the things that we discussed here? These are very, very fundamental concepts. You must know them, right? It's a must know. Okay. Now let's come to the next. And let me also assure you, if you know these concepts and somebody ends up judging you on these and actually ends up asking these concepts in the class, in an interview, I am pretty sure that you are going to make a very, very big, very, very good impression on them, right? You would end up making a very good impression on them. It would actually seem to the interviewer that you have done all these things, you know things in and out, and they can depend on you for you to come up and handle their database. Does that make sense? Cool. Basically, not only handle their database, basically build an application which actually uses some database, and the application is going to give you the correct answer. Okay, makes sense. Now let's come to and also try to appreciate. When I studied this at my college, right, and due to God's grace, I happened to study at a good college. The professor is very good, but to study this, I would say that actually it took the professor to around 7-8 days, 7-8 classes, 5-7 classes to teach this concept that we did in one class and 30 minutes. So you guys should really feel a lot happy कि भाई you got something which otherwise would have taken, let's say, at least 7-8 classes in a real classroom environment, or let's say in a company, it would take you 5-6 months, or मतलब इतने months लगेंगे for you to actually be working on something like this and getting to know these things. Cool. Let's now move to the next topic, which is, let me start the topic by asking one question. Okay. The question is, let's come back to the system design that we were doing before this storage valley class. We realized, okay, so let me just draw the diagram once again. There is a client, interacts with DNS, resolves, gets the IP, goes to the load balancer. The load balancer actually interacts with app servers, and you have a storage layer, which also have some data, which may be sharded with, right? Right. This is a favorite. How many of you are feeling happy after looking at this diagram again? I am, right? I'm drawing this in this class after a while. Right. So, cool. So we are seeing this diagram once again. Now, just because this is a storage class only, we are only going to discuss things about in this layer. Okay? We are only now, whatever we are going to discuss is only for this layer. Okay. Do not assume that this is for any other layer. Okay. Cool. Let me just plug my laptop. हाँ विशाली पक्का ये इंटरव्यू में हाई लेवल डिजाइन कभी भी है ड्रॉ करके जरूर आना यार, ठीक है ना, इसको मत छोड़ना, ठीक है. Cool, cool. So let's yeah, everybody please draw it. Okay, cool. So now let's come here. So you guys tell me, let's say you have a problem, any problem that you're trying to solve, which deals with a lot of writes. Okay, and the writes are actually going to the DB. Okay, so a problem which deals with a lot of writes. Let's not assume कि अभी बहुत सारे boxes हैं. Let's assume there is only one box and it is dealing with a lot of writes. Now I am posing a question. If I just have that one box and make it master slave, can I actually handle a lot of writes using master slave? The answer to that is no. you can end up building a system which is very read heavy from a master slave architecture. We discussed that in one of the classes. I hope that you can end up writing everything to master, and you can end up reading things from slaves. Do you guys remember that? But when the problem is that you want to scale up rights, that is, you have lots and lots of rights coming, then having just one box as a master and having multiple slaves is not going to solve the problem. Does that make sense? Right. Sankalp, that makes sense, but let's not go to peer-to-peer right now. Master slave architecture would not help, right, in that case. Now, the question that I want to ask is, and the answer you already know, if I had one DB and there were so many rights coming and I cannot use master slave architecture, can you suggest something to me so that I can handle lots of rights incoming? Can you suggest something to me? Okay, let's just go through all the things that we discussed in the classes till now. So there is a very common concept. That's okay. That's the answer here. Think about it. Do not reply publicly. Reply privately. Uh, Manish, you're absolutely right. Manish, you're absolutely right. Uzair, you're absolutely right. Baki sab, you are not right. This is saddening. Okay, so okay, the answer to this is that your screen is flickering. Okay, is my screen flickering? It's not. Suganya, maybe it's the issues at your end. Maybe you can rejoin the session. Try rejoining it, Suganya. Maybe it will be better in that case. Cool. So the answer to this is that you will do sharding, right? The answer to this is that you will do sharding. Let me explain why you will do sharding. Okay. So abhi tak we discussed ki sharding actually helps you to have, when you have too much data, when your data becomes too big, you will have a sharded DB. Do you guys remember that? We discussed that, right? If the data is too big, you would just want to say, ki, Acha, I would have some data in this DB, some data in some other DB, and so on and so forth. This is not the only thing which actually is the reason why you go for a sharded DB. Even in cases when you see too many writes happening, even if the entire data is not very big, but too many writes happening, you would want to shard it across multiple DBs so that some writes go to one DB, some writes go to some other DB. Does that make sense? Does that make sense, folks? Because one system, one DB box is limited by the, let's say, the bandwidth that it has, limited by the computations that it can have, limited by just because it would, let's assume it's a SQL DB, or even if it was a NoSQL DB, even if it was a NoSQL DB. Okay, so whatever we are discussing in yesterday's class or in today's class, everything is equally valid for a NoSQL DB as well. Okay? NoSQL DB may choose to give less guarantees, but the concepts that we are discussing actually remains. These are fundamental concepts. This is true for SQL. This is true for NoSQL. Does that make sense to everybody? Okay, it makes sense, right? So now the point here is that in cases of any DB, which would also be giving you some guarantees, the moment you write on it, do you guys appreciate that you would be having to take some locks? The moment you are writing data on any particular DB, do you understand, no matter whether it's a SQL DB, it's a NoSQL DB, if it is giving you any guarantee, do you understand it basically has to take some locks? Right. And the moment it has to take some locks to give you any kind of a guarantee, you guys would appreciate and understand that that's also a bottleneck for a single DB to have so many rights. Okay, let me just rephrase what I said here, and that should be clear to everybody in the class. The point is key, why do we do sharding? Irrespective whether it's a SQL DB or a NoSQL DB, we do sharding for two primary reasons. Your data grew too big. This is one reason you would want to shard. The second reason why would you want to shard is you would have too many write requests. Now, why can't you handle too many write requests in a single DB? You can't handle too many write requests on a single DB because point one, it would be limited by bandwidth. Guys, if anything does not make sense, please let me know. The second would be, it would be limited by computation. Third would be, let's say, just because you're writing something and for some guarantees you would be taking some write logs, so it would also be limited by the write logs that you are taking. Does that make sense? Not even the write logs, even the read logs also. Write or read logs that you are taking. Does that make sense to everybody? Does that make sense to everybody? Right. So Sankalp is absolutely right. We are also limited by the number of concurrent connections that we can have. Limited by concurrent connections that we can have on that DB. Does this make sense to everybody in the class? Right. So these are the two basic reasons why you would want to go with sharding. And for the second reason, these are the primary reasons why you would want to go to sharding. Now, let me explain sharding today very, very properly, because after today's class, I would assume that sharding as a concept is known to everybody बहुत अच्छे तरीके से. Okay. So let me just, for even at the risk of repeating myself, let me just say it once again. Let's assume you had a single DB, or the TB has a table called users. Okay. The users had these fields. Okay. Customer ID, let's assume, the name of that user, or let's say the favorite color of that user. Does that make sense? Let's assume interview bit has gone crazy and we are also storing what is your favorite color due to some XYZ reason. Or maybe you have not gone crazy. We want to order a t-shirt for you and we would want to give you the t-shirt which is of your favorite color. Okay, so if we circulate a type form and somebody fills a favorite color as, let's say, uh, पता नहीं यार, मतलब दिमाग नहीं चल रहा है, मतलब some random वो do not do that because you may end up getting a t-shirt of that color. Cool. Now the now the point here is that you have, let's assume, these three fields in a users table. Okay, and now just because we want to do sharding, what would we essentially do? And let's maybe take कि पहले table में था क्या क्या. Let's assume there is customer ID 1, customer ID 2, customer ID 3. Let's assume the first person was named, let's say, Jack. Second person was, let's say, named Jackson. Third person was, let's say, named Neil. Okay, and let's say their favorite color was something orange, red. Okay, cool. Now sharding basically means horizontally dividing the data. What does it mean? It means कि let's say I am sharding this across 5 dbs, or let's for now assume 5 dbs. So what I'm going to actually do, I am going to have the same table. Nothing changes. I'm going to have the same table, users table only, in all these 5 dbs. Nothing changes, right? The table would again have the same data, same rows, customer ID, same columns, customer ID, name, and the favorite color, customer ID, name, and the favorite color, right? So you understand that you are just replicating that, you are just creating the same table across all the shards, but the only thing is that some rows would be present in this shard and some rows would be present in this shard. Does that make sense to everybody? Is everybody on the same page with this? That the table remains actually absolutely the same, and you just actually write different entries at different positions. Okay, now you can, what is the benefit of doing that? Okay, let's look at an application level. Okay, first of all, let me tell you, the moment you do this, in case of SQL at least, assume this to be a totally independent DB from this. Does that make sense? Assume this to be a totally independent DB from this. This will in itself, this table will exist as if I am the only table that is existing. This table will exist as if I am the only table that is existing. Let's assume that you do not even know about each other. Does that make sense? They should work totally fine, assuming them to be totally different. So the sharding that we end up doing for at least a SQL thing is at the application level. Does that make sense? So at the app server level, you are doing something which will make sure कि भाई हर किसी DB को लग रहा है कि मैं independently मैं ही हूँ, दुनिया में मैं ही सबसे important आदमी हूँ और तो कोई important है ही नहीं है, right? सब कुछ मेरे पास ही है. But let them feel that way. There is an application layer which is actually doing all the sharding parts. Does that make sense? Sankalp, that's right. Partitioning, sharding is one and the same thing only. Okay, cool. So I would just because this is happening, do you guys agree that I can just write and read parallelly? I can read parallelly across these boxes because these are boxes which are totally independent. Does that make sense? So if this box could have actually had 10,000 connections, now I can, if I have 5 boxes, I can potentially have 50,000 connections. Does that make sense to everybody? Simultaneous connections. Cool. If that makes sense, now we need to first of all figure out, okay, let me just actually tell you one more thing here. one thing that I left saying that. So we have mentioned these five, four options why a single DB may need to be sharded across multiple DBs, even if the data does not go too big. One more thing here is sometimes what happens, the index that you are building grows too big. How many of you know what an index is? How many of you know what an index is? What an index is? Everybody knows, right? Do you guys know what a primary index is? What a secondary indexes are? Do you know the difference between primary and secondary indexes? Why don't you know? Why don't we have covered that already? Okay, so in the DBMS lecture we have not covered that. Is that true? We have not covered secondary indexes. Okay, so if we have not, uh, okay, so I will try to give you some brief overview in today's lecture. Cool. Okay, not sure if covered or not. Okay, so I will just give you some brief overview. Cool. So if the index grows too big, do you guys appreciate that the index must always sit in the primary memory? What is index for? Index is for fast accesses, right? Whatever index that you are building, well, of course, you end up saving index in actually disk as well, but some good part of the index must sit in your primary memory. Does that make sense? Only then the index. I make sense. It makes sense, Uncle. Indexes can be stored on disk as well. Of course, they would be, but the point is a good portion of that index must sit on the primary memory. If your primary memory becomes too small, the memory that is available for you to store an index in the primary memory, if that becomes too small in relation with the entire index, do you appreciate that indexes now do not even make any sense? If the ratio is too big, if you are only storing, let's say 1% of the index in the primary memory and storing 100% of it in the DB and only 1% in the primary memory, do you appreciate that the benefit of doing that will not be there? Does that make sense? So you also have one very, very real life condition in which the index becomes too big. You may end up wanting to do shard your DB because the index is too big, because your queries are suffering, क्योंकि queries fast होती हैं index से, and if the index itself becomes very slow to load one by one, बहुत सारे page misses हो रहे हैं, तो your indexing will not be able to give you a lot of better things. Does that make sense to everybody? Now Sankalp is saying that just because indexes are slow, your write would be slow. Is that a good statement to make? Is that a good statement to make? Your writes would be slow because your indexes are slow? No, your reads would be slow because your indexes are slow. Does that make sense? Cool. Makes sense. Let's now move ahead. So we discussed all this. We discussed that the moment we sharded, we can actually read or write parallelly, because you can assume that these are as independent things as possible. Now, can you guys tell me if there is a SQL DB, write would be slow as well? Oh, makes sense. Sankalp, makes sense. The reason why I brought that to our notice, and the primary reason was to maybe tell you guys that indexes as a concept makes your reads speed up, right? And if your index is not performing well, your reads would definitely slow down. For sure, writes will also slow down because you also have to update the index. And primarily in cases where you have to write a lot, indexes are not preferred at all, because indexes just mean that you are updating a lot of things in the index as metadata as well. But that makes sense. But ideally, it would also slow the writes as well, right? But primarily, it would slow the reads. Does that make sense, Sankalp? Are we on the same page? Yeah, makes sense. Cool. Now, if I am making a statement that if you are sharded your DB and you can assume every single instance to be a totally independent instance, can you tell me one very, very big issue that will arise in a SQL DB? One very, very big issue that will arise in a single SQL DB if I'm assuming every one of them to be independent of each other? Exactly, Manish. Manish, Nikhil, you're absolutely right. The problem of joins. Right? So if you have the data which is sitting in one DB and you want to do a join, that's trivial. Does that make sense? Because that's just like any simple join that you do. Big baat to yaar. How many of you are feeling left out? I'm not seeing very good responses today. Is it because you guys are feeling left out, or is it because it's a Saturday evening and you guys are feeling tired? Okay. So I would just want to know that before I move ahead. Okay, Uzair, I will repeat that. But I would want to understand, okay, is it because you guys are feeling tired, or is it because you guys are not finding this interesting, or you guys have had enough of HLD classes and now want to move to something else? Okay. Is there any concern in the class? you can feel free to let me know, right? I am one person that you can always feel free to tell anything that you want to tell me, right? Cool. So everybody's fine, right? Right. Cool, 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 cool. Makes sense. Cool. So maybe I am not fine. Just because it's Saturday evening, maybe I am not fine. So maybe I am. It to me it seems you guys are not fine, but actually I am the one who has some issues, right? Cool. So let's discuss about joins, right? Let's discuss about joins. So I was telling you that if you are joining some information which happens to sit in the same DB, then joins would be as trivial as they were till this point in time. But if you actually end up having data spread across multiple DBs which you want to join, now let me tell you that that join is going to happen at the application level. Does that make sense? So a join which happens in a single DB, when the entire data of the join was a single DB, तब तो normal join के बराबर है वो, even if you have sharded your data. But if you're doing a join which actually has the data spread across multiple DBs, that kind of a join you will be primarily doing at an application level. Does that make sense to everybody? Cool. Now let me tell you one more thing. Just because you appreciate that doing a join at an application level would be very tough. Do you guys appreciate that? Because what would that mean? That you are running the same query at multiple DB instances, getting their data and transferring that data over the network. Now you have that data in the app server. Now you would realize that some of that data may be sitting in that data will be sitting in the RAM of the app server. Now you will be doing a join there. And joins are basically n cross m operations most of the time. Does that make sense? So that would be a lot of problematic thing to do. मतलब application level पे join करना would involve a lot of challenges. First of all, it would involve network overhead. Second, it would fill your RAM at the application server. Third, the computation. Nikhil has actually done that for us. He has written all the 3 points before I wrote. That's great, Nikhil. Are you teaching me or am I teaching you? Okay, cool. So these are the three things that you guys would realize that these are the three things that you guys realize that these are the three problems that you guys would see if you are doing a join at the application level. Does that make sense? Cool. So now we realize these things, right? We realize this. Now there is one very, very important thing that becomes a lot more important just because we realize this. It's that on what basis are you partitioning your data? Does that make sense? This becomes very, very important. This is something which is going to define your knowledge about databases, right? If you end up doing this nicely, your application would be totally fine from a DB perspective. If you screw this up, no matter what you learned, it is of no use. Does that make sense to everybody? So no matter if you're building a SQL system, you're building a NoSQL system, right? No matter whatever you are doing, right? Whatever out of the box solutions you are using, or you're building your own solution, if you screw this up, nothing is going to work. Does that make sense to everybody? So this is very, 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 very important. Okay. And we are going to discuss this in the remaining class. And maybe we are also going to take this to the next class. And so just treat this, whatever we are discussing, just treat this as something which gives you some insights to NoSQL world as well, right? So one primary difference here would be SQL comes with some guarantees that all of us understand, right? वो थोड़ी सी वो हो चुकी है, मतलब those guarantees are very, very consistent, मतलब very, very those guarantees are known to everybody, right? Those are very common guarantees and everybody understands. Standard is the right word to use. Those are standard guarantees to have, right? We all appreciate those things. In NoSQL world, the point is कि you in different NoSQL DBs you end up tickling with different things, right? But fundamentally the concept remains the same. Fundamentally यही हो रहा होगा कि यार you are spreading your data across multiple nodes. Nodes here means multiple DBs. What is the primary thing that makes things the most important is at what key you are partitioning your data. you would understand that, okay, if I'm partitioning our data in such a way, no matter if it's SQL or no SQL, if I'm partitioning data in such a way that in most of the queries that I have, the there is only one partition that I need to go to for a particular query, it's a good way to partition. If no matter if SQL or no SQL, if you're writing partitioning in such a way that your queries are such that for every query you need to get data from multiple DBs, combine them at an application level, do something out of it, you would realize that's a bad design. Does that make sense? Now, NoSQL will be doing some of this job out of the box for you, right? So, but still you can screw that up because your partitioning key was very bad. And even if NoSQL was doing things out of the box for you, the performance will suffer because the fundamental concept is the same. Does that make sense to everybody? So never now worry if you are discussing an interview about a SQL or a NoSQL DB. If you know these concepts, you can be pretty sure that nothing out of them will arrive, irrespective of whatever DB you have. Cool? Okay, makes sense. Now you can always have a logical discussion if you know these concepts well, irrespective whether you know about that specific DB or not. Okay, cool. Let's now move forward. So now on what basis you partition your data is actually going to determine your performance a lot. Okay. Uh, let's now first of all mention what all goals should be there for a partition mechanism. Does that make sense? And some of these things will look repetitive, but there is a distinct difference between partitioning data for the application servers, partitioning requests for the application servers, and partitioning data for the storage layer. Did you guys realize that what did we discuss for partitioning requests for the app server level? What is the best solution that we discussed for, let's say, stateful systems? You guys remember that? How did we consistent hashing, right? We discussed consistent hashing. Here, consistent hashing can also be used in databases. Consistent hashing would be used in several cases, but just because the problem is a bit different, there are some other approaches as well. Okay, so I am redefining the problem. You may see some things that we already discussed, but just try to appreciate what is the difference between an app server level and the storage level. Okay, cool. The first goal that we should have of goals of sharding. What are the goals that we want to achieve out of a sharding mechanism, right? The first goal is that the data should be as equally partitioned as possible. Does that make sense? Data should be as equally partitioned as possible. This is a balanced partitions, as Vaishali put it. The second thing is that you should also try to equally distribute the query load. Does it make sense? The query load that you have, which may have actually the read queries or the write queries, you should also try to distribute this load across DBs as much as possible. Does that make sense? And which in turn would also mean that you would want to minimize your joins. Does it make sense? Exactly. Vaishali, you hit the nail exactly at the correct spot. This is exactly what we want to do. But just does everybody in the class appreciate these two goals? Right. Now this goal, you would understand, is relatively easier to answer, relatively easier to achieve. Does that make sense? You can come up with several strategies which would be just distributing the data equally amongst the shards. Does that make sense? This is easy to answer. But this thing, just because in our database layer, this is another very, very important thing that we must consider about. And this is something for which you do not have a global solution. Does that make sense? Because this is dependent on what kinds of queries do you have. This is dependent on what queries your system is going to see. Does that make sense to everybody? Does that make sense to everybody? I want everybody to appreciate this. Is very, very important. If you do not understand this, nothing else will make sense, right? अपने केस में इन डेटाबेस लेवल में शार्डिंग जो हम कर रहे हैं, it's very, very important that data should be equally partitioned as possible. That's fine, but the queries should also be as distributed as possible. And this is totally how you should go about sharding your database. Now totally depends on what kinds of common queries are you going to see. What kind of common heavy queries you are going to see. Okay, this is something which is going to determine what will enable, what kind of a strategy should you use to partition your data? Is everybody with me till this point in time? Cool. Let's now let's now discuss a problem and let's try to figure out a solution to that problem. Okay. Cool. Let's assume I had a big table. Just may I again had, let's say, let's come up with a good example here. Tell me any query where it would make sense to have people. It would make sense to have things. Okay. So let's assume I have a database. Let's take some example. Let's take I have a database of users. Okay, and the users are uh, this way. Okay, so let's say users का सबसे पहले table में होगा name, फिर the table will, let's say, have age, and then the table will have country. Does that make sense to everybody? Okay. No. Okay. So Sankalp has a very good question. Sankalp asks, can we denormalize the data? How many of you understand what is denormalization data of data? Denormalization, if in your DB MS class you would have realized, normalization basically means that you are essentially creating more and more smaller tables and having your data across different tables. Does that make sense? Folks, does it make sense? Denormalization basically means that you choose to go a step in the opposite direction and say that, hey man, irrespective whatever the theories and irrespective what my teachers have taught me in the class, they have taught me by normalize karo, but वो ऐसे ही बोल रहे थे, which makes sense in some points. I would want to choose a denormalized format here because that makes more practical sense to me, right? And if Nihal would have pointed that out in the class, that there is a very, this is actually which boils down in DBMS. When should you stop your normalization? When should you step back and say, Acha, itni normalization is enough for me. I would not want to do more normalization, right? That is also very important. Okay, cool. So now Sankalp is saying that what if I denormalize my data and have bigger tables? Will that help me to reduce joins? People, does it make sense? Will that help you to reduce joins if you have bigger tables? That will. But is that the only way if you are sharding data? The answer is no. Try to appreciate. The point is that let's say that you were doing the joins most of the times, which were joining data based on user IDs. Does that make sense? Okay, so that's a very good question. Let me just do some digression and explain that. And if there is anybody who's feeling left out, please let me know. That's very important. So Sankalp told me that let's denormalize data. Construct an example. Okay, let's construct an example. Let's take the example that is there on Interview Bits practice website, that you have, let's say, movie ID and you have the movie name. This is one table, and let's movie name, and let's assume or let's take a user ID example. So let's take Interview Bits actual example, and let's take, we have your data, right? So there would be one table which is about users table, right? It would have user ID, and then it would have the user name, and then it would have user email, and so on and so forth. Does it make sense? Then there would be one table in our DB which would be a mentee table. Why is a mentee table different from a user table? Because a user can be a mentee at Scalar Academy, may not be a mentee at Scalar Academy. The user can be a mentor at a Scalar Academy. The user can be a normal free Interview Bit user who just practices questions on Interview Bit, and so on and so forth, right? So you can have different users, different kinds of users, and mentee is a specific kind of a user. And in this table, yeah, you're right, Vishali. In this table, the key would be mentee ID, but there would be one column here which would be user ID. Does that make sense to everybody? There should be one column here because I'm not going to store the mentee name here because that is already stored there, right? I would want to normalize my data. Let's say the third table would be a table which talks about, let's say, your performance in the academy, okay? Academy performance. So if I want to store your academy performance, I would be having one, or let's say overall submissions, problem submissions. Let's say I have a table called submission. I have a user ID, and then I have some submissions ka stats. Does that make sense? Now, do you guys appreciate that I will be joining these three tables based on what thing? I will be joining these three tables based on user ID. Does that make sense to everybody? I'm going to join these tables based on user ID. Now, what Sankalp suggested कि भाई देखो यार joins में दिक्कत है ना, एक काम करो joins करना बंद कर दो. Sankalp suggests कि let merge these three tables and build a bigger table. The problem there would be कि whatever the problems there are with denormalized data, you have all those problems that you would have discussed in DBMS lectures, right? That is the problem. But he says that let's do that because we would not want to do joins. That's right. You would not be forced to do joins if you have a bigger table. But the problem can be solved in a very simple manner as well. Why? Why use a sword when you can use a needle, right? You can use a needle here as well. Why? Let's assume that your sharding key was user ID. Your sharding key was user ID. Now, what does that mean? That means that these three tables are going to exist on every shard. You're doing a horizontal sharding. All these tables are going to exist on every shard. For a specific user, let's say there is a user ID named Tarun, and I have some specific ID. Then now, whatever user ID 101 की जो भी rows होंगी, that will be there on one single shard itself. Now, even if you want to do joins, those joins are going to be intra-DB joins. Does that make sense to you folks? So you could have just used a good partition key, which would have, even then you could have normalize your data and do joins, but these are intra-DB joins, which are very easy to do. Sankalp, does it make sense? Right. So why use a needle? Why use a sword when you can use a needle? Right. Okay. Why use a needle if you can use a sword? Right. मैं बस sword घुमाता रह सकता हूँ दुनिया में और मैं needle क्यों इस्तेमाल करूँगा? Right. I don't know if you guys got the joke or not, but that made me laugh. Right. Cool. Cool. So you can actually still normalize the data, but still if you use a good partition key, you can ensure that you have intra-DB joins, which is totally fine. I hope it makes sense. Right? Cool. So let's take an example now. We were on the topic that we need to make sure that just because you want to divide your query load properly, it's very important that you look at what kinds of queries you have and then decide on a partition key. Does that make sense, everybody? What kinds of common queries do you have? And then decide on a partition key. So we were looking at this example. Let's assume this is the table that you have. The names start with, let's say, ABC, किसी बंदे का नाम है, ADC नाम है. There is a person whose name starts with B, C, D, E. Now let's say the queries that you have are kind of range queries on name. What does that mean? That means that whatever queries that you're going to see are going to be mostly range queries in which you are going to ask, tell me all the folks whose name starts with A to E. Tell me everybody whose name starts with, let's say, B. Tell me everybody whose name starts with Z, right? Tell me everybody whose name starts with U. If you see queries like these, range queries like these very often, what kind of a mechanism of sharding would you want to use? That's the question, right? And Beshali has given us the answer, but we would define that in a much better way here once again. So what is the problem? The problem is that you have a bigger DB, a DB, let's say, with millions and millions of entries, where you have let's say billions of entries. Let's assume you are talking about Facebook, and it's a strange kind of a Facebook which let's say has to do a lot of queries figuring out people whose names start with a particular alphabet. Okay, or let's take a better example. Let's take Google search ka table. Let's assume you have a Google searches ka table. Does that make sense? Is everybody on the same page that it is going to have billions and billions of entries? Does it make sense? And does it also make sense that it's plausible that Google would want to have queries which talk about figuring out the queries which start with A or which start with B, queries which start with C? Does it make sense? That they would want to do some kind of a range queries. If you want to do range queries, your partition strategy should also be such in which it would enable you to do range queries easily. Okay, so let me tell you how to do it. The way to do it is if you have your partition strategy based on key ranges. What does that mean? It means that you are going to partition your data based on key ranges. You will say that whatever starts from A to B should go to the first DB. Whatever starts from C to E should go to the second DB. And let's say whatever starts from X to Z should go to the last DB. Does that make sense to everybody? Does that make sense to everybody? So your applications would know there should be one kind of a box here which is going to help you with do this, uh, which can be any kind of a load balance. Let's not call load balance. Let's call it any application logic. You can just write that logic in the application itself, which will just enable you to figure out which particular DB do you need to go if you have some kind of a query. Does that make sense? So let's say there is some query which is update a row, or let's say there is some query which inserts a row and where the name actually starts with C. Do you automatically know which DB to go to? Right, you know automatically which DB to go to. So you're going to go to this second instance. All right. Similarly, if let's say somebody is trying to figure out a select query, somebody is saying select all from users, where let's say the uh, name let's say starts with A to E. Let's say A to F. Now you want to figure out whether name starts from A to F. This is a range query. Do you understand? These are range. These are queries where ranges are important, right? And if it's a range query, A to F, now your application knows here A to F primarily compromises of A to B, C to E, and F to something else. So now you can actually just create this one query and make this into 3 queries. Does that make sense? So we'll figure out select all from where users belong to A to B, where users belong to C to E, where users belong to F to A. So what you're going to do, you're going to run this query on the first instance, on the second instance, and on the third instance. Does that make sense to everybody? Right. So do you understand that? So this kind of a thing would be done at the application level by yourself in case of a SQL DB. In case of a NoSQL DB, the NoSQL DB will give you out of the box solutions to do this. Does that make sense? Does that make sense, folks? But the concept remains the same. So you may end up using this kind of a key range mechanism in which you can do stuff like this. Is there anybody in the class who feels left out? Okay, makes sense. Exactly. Manish is asking the right question at the right time. I was just about to discuss that. So do you guys realize that when we were doing the consistent hashing thing, we discussed that this is not a good approach. Did we discuss that? That key based partitioning is not a good approach. Can you guys tell me the primary reason for saying that? The primary reason for saying that is, what if the boxes go up and the boxes go down, right? So what if you want to scale up or scale down? And that is something which is a must to do, right? You will end up doing scaling up, scaling down, because your number of resources, that number of requests that you're getting will keep on changing. Does that make sense? Folks, does that make sense? The number of operations that you end up doing will change a lot frequently. But here is the primary distinction. In case of databases, you are not going to see, when do you want to add a new DB? You want to add a new DB when you have so many new users that you now want to add a new DB. Does that make sense to you guys? The frequency of scaling up or scaling down, this is not called scaling up. First of all, this is not called scaling up. Scaling up primarily deals with computation resources. You want to scale up your computation resources. You want to add an app server. You want to delete an app server, right? So scaling up in case of computation, in case of the app server layer, is very, very frequent. If you have seen your AWS account of your companies, you would have seen that most likely you scale up every few minutes or every few hours at least, or scale down every few hours, right? But the DBs, have you ever seen any company which is going to say that I add a new DB every hour, or I add a new DB every day, I add a new DB every 15 days? No. Does that make sense? DBs are much more static when compared to your app servers. Does that make sense to everybody? And just because DBs are much more constant, that is, you do not just keep on adding DBs based on your whims and fancies and removing DBs based on your whims and fancies, the problem of partitioning based on ranges does not exist. Does that make sense? Folks, does it make sense? Because the primary problem there was you would have to reshuffle your data, reshuffle your resources just because when you add a new resource. And that is where consistent hashing was a very, very cute way to solve it, right? Consistent hashing said, yeah, I'm just going to move very little amount of data and enable you to do something. But here, this is not a requirement, right? So key ranges are totally fine with me. Is there anybody in the class who fails to understand this, what I just said? Everybody understands it, right? And Manish, that's a great question at the right time. I feel very happy when I actually see a class like this where are you guys preempt me, right? And that sort of tells that you guys are getting the concepts, and that really is immensely heartening to know, right? Cool. So we understood key ranges. Okay. Now let's discuss a very good technique. So I would not go into greater details there, but I will just mention that because that's something that I've seen. So I have seen somebody mentioning that to me in an interview, and uh, that sort of makes you feel that yes, somebody knows something. So let me just mention that if you want to read it, you can read it yourself. So there is a concept called as LSM trees. Does anybody know, have heard about LSM trees? Anybody in the class heard about it? Okay, no, cool. So LSM trees की full form होती है कुछ इस तरीके से, log structured merge trees. So something like this, right? Log structured merge trees, right? So this is a data structure which gives you one guarantee. What is that guarantee? The guarantee that this data structure gives you is that in the hard disk, you can give a key to this tree. You can give a key to this tree, and it will always store data in the hard disk sorted by that key. So let's assume the key that I gave was the name. So all the names in the actual hard disk. So do you understand that databases are actually stored in hard disks? Do you understand that? Right. So when it actually gets stored at the hard disk, you would realize that this data structure, LSM trees, allows you to store data sorted based on a key. So let's say there is a name ABB. That would definitely come before any name which is ABC. That would definitely come before which is any name which is ACB. Would definitely come before a name which is AD. Would definitely come up before a name which is starts with D. Would definitely come a name which starts with ZAC. Does that make sense? So I'm not going to detail how this is actually happening, but just appreciate that LSM trees allows you to store data in a DB in a sorted order based on one key that you supply. Does that make sense to everybody? Now we are going to appreciate that why LSM trees add a lot of importance. First of all, let me tell you, LSM trees are actually used in Cassandra. Have you guys heard about Cassandra? Right. So Cassandra actually uses LSM trees. Right. Yeah, you're right, Sankalp. So I'm not willing to mention a lot of definitions here, but the point would be that if I end up, if I end up doing that would make you guys prone to use those terms in interviews, and anybody that any interviewer sees using a term that they do not understand, that's a straight reject. You can very well avoid using terms. That's not a reject. Does that make sense, Sankalp? If you do not use some fancy terms, that's totally fine. And everybody in the class, please take one thing out of this course. Do not just use fancy terms in an interview. The moment you use fancy terms, the interviewer will want to test whether you know them or not. Does that make sense? Not mentioning term and only dealing with the conceptual things is totally fine. Folks, do you understand that? Discussing things at a very, very fundamental level and giving them answers is totally fine. You can skip mentioning LSM trees as well. I just mentioned it because I would want you guys to read about it. And this is the kind of a feature that it provides. And this is used in Cassandra, and Cassandra is something that we are going to discuss in one of the further classes. And that's the only reason why I wanted to tell you this. Okay. So Cassandra में use होता है. Cassandra के अलावा this is also used, let's say, in a DB called as level DB, a DB which is called as rock DB. So these kind of DBs के अंदर आपको इस Cassandra use होता है. Does it make sense? LSM trees use होता है. Just a minute, folks. Just a minute. Right, cool. So, okay. So LSM trees gives you this functionality that you can store data in a sorted order in your hard disk. Okay, cool. Now, uh, this makes the key all the more important. Does it make sense? So now you need to figure out what kind of a key would you want to have. Folks, does it make sense? Because if you are ending up doing range queries, the key of your partition should be a good key, because you should always go to a few partitions and not to every partition. And this is one thing. And also the key for your LSM tree should also be a key which enables you to do good partitioning, which enables you to do faster queries. Now let me explain to you why it matters, right? So let's assume I am going to do a query which asks me कि भाई बताओ यार कि all the people whose names start with AB, and let's say till their name starts with AZ. Folks, does it make sense? Can you have a query like this? You can have a query which says कि यार tell me all the names which start with AB and end at AZ. Let's assume your partition key was this. All the names starting from A to C are in partition 1. All the names starting with D to F are in partition 2. All the names starting from G to H are in partition 3. Now, just because this is the query, can you tell me what partition should I go to? Can you tell me what partition should I go to? Okay, so the very first thing that you should know is that you should go to this partition. Now, if inside this partition, you ended up storing data based on timestamps. Folks, please be with me. If you ended up storing data based on timestamps, and now you want to run a query which tells you A to B, batao, A to Z, batao, do you understand that's a bad query to run? Because if you are storing data based on timestamps, there may be a AB which is at the beginning of the TB. There may be a AB which is at the end of the TB. Does that make sense? So what will you have to do? You will have to do a full table scan. And what is a full table scan? So let me just write full table scan. And let me just make you guys appreciate that why that is a very, very big deal. Because computations do not run at storage level. Does that make sense? So what will you have to do? You will have to fetch pages from the hard disk and bring a page to the main memory. So let's assume this is your main memory. You will bring a page there. In that page, you will find all the names which follow this pattern and write them at another instant in your main memory. Then what will you do? You will remove this page, get the next page from the DB. And this way you will end up doing a lot of page accesses. So you will have to seek your pointer of the hard disk at a different level, get a page, do some computation, store the derived information in the main memory, go to the next page, take it, bring it to your main memory, do some computation, store it in the aggregated storage. Does it make sense? How heavy will this process be? Because computations do not occur at the storage level. Computations occur at the memory level, right? This is going to be very, very expensive. Full table scan is very, very expensive. And do you guys appreciate it's not about SQL? No SQL may it follows the same thing. Folks, are you with me? So I have seen people who would just go in an interview and say, yeah, this is the problem, I would use Cassandra. And चलो भाई हो गया, अब चाय लाओ यार और मेरे को ऑफर लेटर दे देना, ठीक है, चाय वाय पिलाओ और ऑफर लेटर दो यार और मैं घर चलता हूँ, क्या बता दिया Cassandra यूज करना है और क्या लोगे, जान लोगे बच्चे की. The problem there is no matter what DB you use, that does not solve the problem, right? Just by saying a name, that does not tell you that you know how to solve the problem, right? Because the problem still boils down to this fundamental concept that would you actually, if you are ending up doing range queries, how would that range query be executed? कोई नो सीक्वल कोई जादू नहीं कर देगा कि भाई देखो क्या बोलते हैं, भगवान ने ये आशीर्वाद दिया नो सीक्वल इस दुनिया को कि भाई जादू कर देगा. That's not the case, right? It still has to fundamentally work on the same storage, fundamentally work on the same main memory and do stuff, right? So these are concepts that are important. So now just because you want to do a query like this, storing them based on timestamp is not going to help. You have to take use of this relationship called as LSM trees, which will allow you to store data based on keys. And now just because now the data is stored in keys, what will you do? You will, and now you have an index, right? You can have an index here which will tell you कि यार AB से शुरू होने वाली rows इस page ID से शुरू होती हैं और AC से शुरू होने वाली इस page ID से शुरू होती हैं, and so on and so forth. So what you can do using the index, you can just take your pointer to the first. So let's say you want to build from AB to AZ, you will take your pointer to beginning of AB, and from then you will do a page access, and you now know that the page that you've accessed, every single entry in that page is usable to you. Does that make sense? Not basically not every single, so maybe the point maybe कि उस पेज के बीच में ही खत्म हो गया, बाकी की entries not usable है, but entries that you fetch in order are always usable to you, right? So let's assume if from A to B to A to Z you wanted to do 5 page accesses, you can be sure that for the first 4 page accesses, every entry in the first 4 page accesses is important to you. So you are not wasting any entry in any of the page accesses. Does that make sense to you? And does it make you realize that this is the best way that you can do? There is no fundamentally better way of doing it. If a page size is a given page size and you want to read data which spans over 5 pages, you will have to bring 5 pages to your main memory. There is no possible better way out there which will help you otherwise, right? So you will have to do 5 page accesses. The very first 4 of them will give you every single entry that you give you will be important to you. The fifth one may have some of them important, some of them unimportant, and that's totally fine. Does that make sense to everybody? So this will enable you. Okay, right. Nikhil Bhargav is absolutely right. Nikhil Bhargav now says that writes will be a bit heavier here. That makes total sense. But that is something that you should leave for LSM trees to handle. That's why I told you that data structure. Go and read about it and figure out how writes are handled. Does that make sense to everybody? So we discussed this, and now we appreciate that the partition key is very important, and the key in which you want to store your data is also very important. Does that make sense to everybody? Does that make sense to everybody? Cool. Let's now maybe discuss a couple of more examples, and then we would want to discuss some examples in which this kind of a partitioning mechanism would not work, and we would want to discuss some other partitioning mechanism. And it's 11 already. I would want to maybe end the class by 11:40. Okay, I hope you guys are fine with that, right? So there are very few people already in the class. Please don't leave it. If you want to leave, let me know. I will end it early and discuss the next things in the next class, but do not leave, right? This is very, very important. Cool. So we discuss this. Now let's actually try to take some interesting examples and see what kind of a key would you want to use. Okay, cool. So let me just write for the sake of clarity that the benefit here would be less page accesses from storage. Does that make sense? Oh, the screen is not visible. Is the screen not visible? Okay, let me just share it once again. Is it visible now? Cool. So I was writing, the benefit here is that you have less page accesses from storage. So there is one distinction. So some of the definitions call the page once in its a memory a page, and once it is in a DB they call it a frame, but nothing really changes, right? So it's just basically frames, pages, nothing really changes. Cool. So you have less number of chunks accesses that you end up doing, right? Now let's actually discuss a particular example, and you guys tell me what kind of a partitioning mechanism would I want to have, and what kind of a okay, cool. Right. So let's take an example. Let's take an example of interview bit. Okay, interview bit would, let's say, have, let's only talk about mentee IDs for now. Every mentee would have a badge ID, and let's say this is it, right? Every mentee would have a batch ID, and let's say a sub batch ID. So what is a sub batch ID? You guys would be knowing that you guys are divided into smaller flock groups. Is that right? So you guys have sub batches IDs as well, and all of you happen to be in September batch. So your super batch ID is 1. Then you happen to be divided into 2 batches. One is Elite X, one is Super X. That is the second level ID that we have. The third level ID is that every Super X will be divided into smaller batches of 20-25 people for a single TA to handle, and so on and so forth. Does that make sense? So basically there are hierarchies to IDs, right? So there is a mentee ID, there is a batch ID, sub batch ID, and let's say there is another ID. So let's just call them ID 1, ID 2, and ID 3. Cool. Now let me tell you, let's assume an interview case where the queries which are range queries are very, very likely. That I may very likely need to access data of students who happen to be in the same global batch. So let's say I want to fetch data of everybody who studies in the September batch. Let's say I am taking a class and I'm only teaching Super X, and I want to see which student is doing how well, and which student should I focus more my attention of or let's say I'm deciding whether I should take a super X batch or elite X batch, and we just need to look at the data, compare data performance of super X and elite X, and see which batch requires more help, and so on and so forth. So now if you want to have these kinds of queries, do you realize that range queries are going to be very, very common? Do you guys range queries are going to be very, very common? Now, the moment you guys realize that the range queries are going to be very, very common, do you guys realize that your partition key should be such that the range queries are optimized? Does that make sense, folks? So first of all, let me tell you, this is a false example. This is a fake example because interview actually uses single DB shard. So we have not sharded our DB. We just have a single DB which has, let's say, 500, 700 GB of storage and let's say 32 GB of RAM, and that's sufficient for us because our DB is not very big. We have bigger tables, let's say submission tables, which have millions of entries, but we store uh, the earlier submissions in a cold storage. Does that make sense? So somebody, let's say Beshali submitted a code 10 years ago, and that's not going to be really relevant for Beshali, right? So we can just store that in the cold storage, right? So we just have one DB, one single DB instance. But that does not mean that we're always going to have only one single DB. We may become a big university which teaches, let's say, lakhs of people, and we may want to have multiple shards, right? Cool. So now let's come back to this thing. Let's look at this fake example, and let's assume that interview bits DB was sharded across, DB was sharded. Okay, it was spread across multiple DBs. Now, if I want to do a range query, and my range query, now can you tell me what kind of a key should I have? Partition key. So you tell me what partition key should I have? Should I have the ID3 as my partition key? Should I have ID3 as my partition key? No. Should I have ID2 as my partition key? No. Should I have ID1 as my partition key? Yes. Should I have Menti ID as my partition key? Should I say कि भाई एक काम करो Menti से partition मार दो? ठीक है, बढ़िया, Menti ID से partition मार दो. नहीं, so you would not want to do that, right? So the partition ID here, partition key would most likely be ID1. But let me tell you one thing more. So partition IDs, you can create an ID yourself, right? So all of you agree that ID1 is a better choice than ID2, which is a better choice than ID3. Does that make sense? And all of these are better choices than Menti IDs for these kind of queries, right? So I am writing in order of better choices, right? Now, would you tell me, would a ID something like ID1 underscore ID2 underscore ID3 would still be a better choice than that? Maybe, maybe not. Think about it. The answer to it is no. It's not going to be a better choice. The point is, did you realize what did I do here? I just concatenated three IDs. Does that make sense? Folks, does it make sense? So let's assume, what did I do actually? I said, let's assume there is a batch ID, which is 101, and every batch ID has multiple sub batch IDs. So let's say 101, और इसमें दो sub batch IDs थी, एक थी 1, एक थी 2. And now every sub batch ID has multiple sub batches ID, right? So उसको 1, 2, 3, 4. Now what did I do? I said that my partition key would be 101 underscore 1 underscore 1. 101 underscore 1 underscore 2. 101 underscore 1 underscore. Does it make sense, folks? Okay. And if, okay, so I said it's not a good choice, but that's not true because I thought of consistent hashing. Here we are discussing range-based keys. Okay. Now you folks tell me, if I have a range which starts from 101 XX X to 102 01 1, is it a better range than saying 101 से लेकर 102? I hope you guys realize it's a better range. Why? Because it gives you more क्या बोलते हैं, understanding, more specific understanding, right? But appreciate that this as a partition key is not very better than ID1. I will explain that to you in a bit. This is not very better than ID1. This is more or less equal to ID1, but you can say that maybe it gives you a bit more control. But hold on to this thought, and we will come back to this in 5 minutes down the line, and we will see that why this happens to be very better in a specific case. Folks, are you with me? Are you with me? Cool. So do you appreciate that the ID may not be something which is there in your DB? you can just create an ID on the fly, right? You can just merge some things and do some fancy stuff. And this is what we do all the time in NoSQL DBs, right? In NoSQL DBs, in let's say Cassandra HBase, we do these things all the time, right? Back in my company, in Media.NET Direct Time, when we actually had data which spreads across multiple shards, this is something that we did all the time, right? Because if we did not do it, then the queries would be very, very unoptimized. Okay, so okay, which DB do you use? We use SQL DBs in IB, Nikhil. In Direct I, we used to use HBase, we used to use Cassandra, we used to use SQL DBs, we used to use different things for different things. Okay, cool. Let's now discuss something that Beshali mentioned. So Beshali is mentioning auto increment. Okay, so Beshali, you mentioned that in a different sense. You are saying that maybe that you can have that as a key. But let me just because you mentioned auto increment, I remember one thing and I must tell you that. So have you guys seen DBs in which some of the entries can be auto incrementable? Have you guys seen that? So let's say maybe some ID, some row ID, right? So that always gets auto incremented. So whenever you add a new ID, whenever a new row, you need not mention this particular column because this is something. Okay, so Nitesh, this may not be the primary key always. The primary key can be something else as well. But this is something which just maybe you can have an auto incremented ID as well, a row ID, right? So let's say if you add a new entry here, it will be 6, right? If you add a new entry here, it will be automatically 7. So you realize that auto increments are very easy to do when you have one shard. Does that make sense? When you only have a single DB, it's very easy to do because you're only going to one particular box and you can very easily write a logic for auto increment in the DB. But when you have multiple shards and you want to get the functionality of an auto increment, and if you want your IDs to remain unique across the boxes, do you realize that won't be possible? Let's assume you were using MySQL boxes and I told you that you can just assume every shard to be existing as an independent shard altogether. So do you realize that that won't be possible? So for that, what do? We actually have a single computation box, which is a single point. Now, every time we want to have an auto incremented ID, all of them make a call to this, and this guy returns a new ID, which is a consistent ID, and all of them have unique auto incremented IDs. Does that make sense, folks? So this is how we solve that problem. So there is a problem of auto increments in case of sharded DBs. This is how we solve it. I hope it makes sense, right? So this, in at least in the SQL versions that I have used, this problem, this thing does not come out of the box. You have to implement it yourself. But maybe there may be some SQL version that I do not know of, some kind of a DB which would be doing it out of the box. But I'm no one to comment on it. Okay, cool. Let's now move ahead. But conceptually, you understand that you would still require, irrespective if it comes out of the box or not, you would require one single point where you are going to make calls and get that ID. Does that make sense? Fundamentally, nothing changes. It can be provided out of the box. If it's not provided, you can build it yourself. Cool. Let's now maybe discuss one more example, and that would take us to the concept of compound keys. Okay. Everybody with me till this point in time? Anybody feeling left out? You guys appreciate what we are discussing, right? Appreciate it completely. Cool. Let's now discuss the next thing that we want to discuss. Let's take another example. Let's assume there are several sensors which are sending you a lot of data every minute. So every minute you are getting some data. Does it make sense? So let's say it's an IoT world and you have sensors all across, and the sensors are continuously sending you data. Folks, does it make sense? Right. So let's say the data that they are sending is of this type. Let's say first of all they are sending the date. So what is the date today? The date is 18th. So let's say 18th April 2020. This is the date. The time it's 11:17 p.m. IST. So 11:17 p.m. IST. They sent this time. I wrote an extra I in IST. I don't know why. Right. Then let's say they also talk. There is one row which talks about what kind of a entry sensor is this. So let's say this is date, column for date. Let's say this is the column for time. Let's say this is the column for sensor, which you say, let's say the heat sensor, and let's say the reading, and the reading was 35 degrees Celsius. Okay, cool. And let's say you have another entry at 11:18, So you have 1804, 2020, 11:18 p.m. IST. Again a heat sensor. You have 36 degree, and so on and so forth. Does it make sense, folks? And let's say you have also have a location wala thing. Makes sense. Cool. So now you have this kind of a table that you have, and these are the entries that are coming to you all the time. Now let's say the primary query that you have, the primary query which you want to optimize your database for, is that somebody would ask you, can you tell me the average reading on a heat sensor, for the last 24 for the last 24 hours. Okay, so let me write a query. Okay, so let's say somebody says, let me just not 24, let me just write a simpler query. So let's just select the average reading average reading uh, from this table, जो भी इसमें टेबल का नाम होगा, from table जो भी टेबल का नाम होगा, where sensor is heat and the time that you have is less than 30 minutes ago. Does that make sense, folks? Less than equal to 30 minutes ago. And of course, you will not be writing it like this. You will be writing it based on dates and time. Does that make sense, folks? Now, do you appreciate that this is a range query? Do you appreciate that this query wants you to access data in a range? Does everybody in the class appreciate that? Can you now tell me, based on this, can you tell me a good partition key? Can you tell me a good partition key here? And I would want everybody to reply. Okay. So Lokesh is saying that you should be doing a sensor partition. Uh, Manish is saying that you should be doing a time partition. Sankalp is saying you should be a date time partition. Then there's somebody who is saying a date partition, and so on and so forth, right? Can it be a year ago as well? Uh, let's assume no. Let's assume the common query that you have is for the last 30 minutes. This is what they want to understand. Last 30 minutes. Okay, these are the columns, Vaishali. So everybody just tell me that. Cool. Uh, okay. Okay. So Uzair had asked a very good question. Uzair says, can there be more than one types of sensors? Let's actually simplify the problem, and let's assume the entire table is only for heat sensor. Does that make sense? So let's assume this entire table is for heat sensor, and that actually makes sense. So maybe you would want to have different tables for different kinds of sensors. Now, let me just mention a few options, and I would want to understand how many people feel that as an option. Do you want me to have a poll, or that would take more time? Let's not do it. So one option would be here, that you can actually have based on date. Does that make sense? The other option that you can have is maybe you can have it on based on time. Other option that you can have is you can have a based on reading. Then maybe you can understand, then maybe date underscore time, and then maybe time underscore date. Anybody else who feels anything else should work here? Anything else out of these? No, right? Cool. So how many of you feel that, let's assume, reading should be the, how many of you feel reading should be the uh, key for partition? Anybody in the class who feels that? No. So reading should not be the key of partition. Let me explain you why. So if you say कि यार मेरी एक डीबी में सारी वो एंट्रीज आएंगी, 35 डिग्री सेल्सियस आ रहा था, एक में all the entries in which 36 degrees Celsius were there. And of course, try to understand, you will not only have one entry mapped to one dB. Does that make sense? Folks, just do you understand? It's not the case that it's a one-to-one mapping, right? It's a many-to-one mapping. So you would, let's say, have 35 here, and let's say 42 here, and let's say 17 here, and let's 36 here, 36.5 here, 37.5 here, and so on and so forth, right? Now, let's say if somebody wants to figure out the last 30 minutes, what was the average temperature, would you agree that you will have to make that query on every single shard? Does that make sense, folks? So this is not good, because you will have to query every single shard. So that's a very, very bad design. right? So this is not done. Now let's say you would want to do it on time. Does that make sense? So time का क्या मतलब है कि let's say 12:17 IST PM would be one ID, would be one partition ID. Then there would be 12:18 PM IST would be another partition ID. Then there would be, let's say, 12:19 PM IST. Do you guys realize that this is something which will help you? No, because if you want to look at the last 30 minutes, then whatever is the current time, you will have to go to at most 30 partitions. Does that make sense? You may end up going to less than 30 partitions because ऐसा हो सकता है कि some of them happen to be on the same partition, but that's only by, that's okay. So if you have a range query, you can actually still use a time. Does it make sense or does it not? So let's assume you have range key partitioning strategy here, and let's say 12:17 से लेकर 12:47 तक will be there in the same box for sure. Can you use it now? You can still use it now, folks. Does it make some sense? But the problem would be that now for that particular time, you will have the data for every single date out there. Folks, are you with me? Are you not with me? Right, you are, right? So, okay. So, but still, this is not the best way. The best way, in my opinion, would be date, or let's say date underscore time. You can either use date or date underscore time, right? That would give you balanced partitioning. Sankalp, even if you take time, that would also give you balanced partitioning if your problem is such that the sensor is sending you data every minute. Does that make sense? So in fact, even time you can also use. Nobody's stopping you from doing that. That's also fine. Now let me just explain you one thing, that there is a concept of compound key. What is the concept of compound key? Compound key basically means that you have two keys, one key which is used as your partition key and another key which is used as your sorting key. Does that make sense to everybody? There are two keys. Compound key is basically a tuple of two keys. Everyone please pay attention. It's a tuple of two keys where the first key that you have is the key that you use to partition your data, and the second key is the sorting key which you use for the LSM tree to store your data. How many of you appreciate it? Folks, I would want you guys to reply. Right. So can you tell me now, once you know the concept of compound key, can you tell me a good partition key? I would say a good partition key would be date, and a good sorting key would be time. Does that make sense to everybody? Does that make sense to everybody? Right. So basically you will have a good partition key would be date and a good sorting key would be time. Right. Now let's say this is the most frequently asked query. This is the most heavy query that you wanted to optimize for, and you have created your DB according to it. But now let's say there are some other kinds of queries as well. Let's say there is a query, tell me the number of times the temperature was between 30 degree to 40 degrees Celsius on let's say 27th April 2019. Tell me the number of times the temperature was between 30 to 40 degrees Celsius on 27th April. Can somebody tell me how will this design help you? Will this design not help you? If yes, can somebody take me through it? Is the question clear? Now let's assume there is some other query as well, which is not the most commonly asked query, but this is this kind of a query that you want to figure out the number of minutes in which on 27th April 2019, in which the temperature was 30 to 40 degrees Celsius. Can somebody help me with this? Anybody would want to volunteer? Sure, Nikhil, let me unmute you. Hey Nikhil.
Yeah, hi Tarun.
First of all, how are you doing, man?
I'm doing good, man. What about you? Saturday.
I'm doing great. I'm doing great. Cool.
Yeah, that's good.
Yeah. So now you tell me, Nikhil, that first of all, do you realize what is the partition key for our table that we decided?
Yes. Yeah. Partition key currently is date, and sorting key, as we decided now, as of now, is time.
Makes sense. Now you tell me, this is the query that you want to do. This is, let's say, at the query at the application level. This query is not at the DB level. This query is the application level. First of all, looking at this query, can you figure out the partition that you should run this query on?
Yeah. So like looking at this query, we can figure out like which partition it will be at, right? Because we have
the shard would be the shard which has the data for 27th April 2019.
Yeah.
Does that make sense to everybody? Just by looking at this query, you can figure out that only one shard is important to you, which is 27th April 2019. Does it make sense to us? only two people are replying. Yeah, it makes sense, right? Cool. Right. Now you tell me. Now you figure out the chart. Now what will you do?
Now basically we need basically on that table we'll be doing a full either a full table scan or if we have an index over this thing as well over the readings, in that case that also can help.
Makes sense. So that's why I asked you guys about primary indexes or secondary indexes. So there is one primary index. Any table can only have one primary index. This is something that you should already be knowing, but please appreciate any table can only have one primary index. Any doubt in that? There is no table which can have more than one primary index, because primary index is the index which determines the ordering in which it is stored in the in the hard disk. Can you
Primary.
actually have more than one ordering due to which you can save in the hard disk?
Yes.
Folks, I would want everybody to reply. That's not practically possible, right? So primary index was only one index, and the LSM trees help you with the primary index. Does it make sense?
Yes.
And here the primary index was based on time, and that primary index is of no use to you because you actually now want to look at a range of temperatures. Does that make sense? Now, Nikhil, the way that you already suggested here would be that you build a secondary index on temperature as well. So you build
Temporary.
a secondary index on temperature.
Yes.
Does that make sense to everybody? That's it. And that secondary index will help you to speed up this query, and you are good to go. Nikhil, does that make sense?
Yes.
Nikhil, just let me just ask you one follow-up question. Let's
Yes.
assume this was not the query, but the
Okay.
query was this, that I want to count all the minutes where
Mhm.
temperature was between 30 degrees Celsius to 40 degrees Celsius in the last 2 years. What will you do?
2 years. 2 years. So, like, first of all, can I question like in how much date 1 dB will be, one shard will be containing that of any date
Makes
or
sense.
something?
So you are exactly on the right track. So the point here is that you would have to, if this was a range key partitioning,
Range. Yeah.
in which you are partitioning based on dates, you will have to figure out how many partitions will have the data for the last 2 years.
2 years.
For that to estimate, you just need to look at the average number of days per partition. But of course, I appreciate that not every partition will have equal number of days. So I told
Yes.
you an example. So maybe A to C can be sitting in one partition,
Yes.
and B to Z can be sitting in another partition.
Yes.
That is something that you can decide based on the frequency of things that you see. Folks, does it make sense? Nobody is saying you that the partition should be of equal size, right? The partition should primarily be of equal storage capacity. It should not be based on equal anything else, right? So maybe the names that start from A to C are more frequent than the names that start from D to Z, and you can just have these two partitions. I hope it makes sense, right? So now you just look at the average number of days per partition. Looking at that, you would figure out how many partitions will you have to go to, and if the partitions are too big, then the number of dBs that you have, then essentially you will be going to every dB.
Every.
Does it make sense? So I will just explain that to you once again. So let's assume the dBs that you have were 10. Okay? And every partition that you have only has 20 days of data. Now if 2 years, 2 years basically means how many days? Roughly 700 days.
Yes.
Folks, are you with me? 700 days, right? If you end up taking the number of partitions out of 700, it would be 35. So basically now you need to check, now you need to check that, okay, just because this is range key, you would realize that 35, matlab in 10 में से if this was storing, let's say, data for 20, let's say this was storing data for 10 years, it would essentially mean that you would only need to go for the first 2 dBs. Does that make sense? Because you were looking at 2 years. Folks, does it make sense to everybody? Right. So does it make sense to you, Nikhil?
Yes.
Okay, thanks a lot. Can I mute you back?
Yeah. Sure. Sure.
Okay, thank you. So we now realize that secondary indexes would be helpful here. Now let's move to another thing, which will explain the reason. Maybe not the reason, but which will explain the bottleneck in this approach. Can anybody in the class tell me that why key range approaches are key range partitioning is not a good way to partition? We discussed already that adding new boxes and removing boxes is not a concern here. Can somebody in the class tell me why key range boxes will be a bad strategy to have in some cases? Can somebody help me with that? May not be balanced load. Okay. So Manish is saying may not be balanced load. That's a good thing, But let me ask you one thing, Manish. So we discussed at the beginning of this session, we discussed that there are two things that you would want to optimize for, and the two things here were that the data should be equally partitioned, and the query should be partitioned. So what do you think? Will the data not be equally partitioned, or will the queries would not be equally partitioned on the shards? I would want everybody in the class to reply. The queries would not be equally partitioned. Does it make sense to everybody? Because all the write queries are happening for today. I am not making any write query for 2 years down the line. Does that make sense to everybody? And if every write query that is happening for today, then don't you realize that shard that has the data for today will be the only shard in which I'm writing? Does that make sense, folks? Isn't that too stupid that we did not realize that till now? Right. So in problems, in several problems, you will figure out the problem of hot shards. This is what we call as hot shards. What is hot shards? So I told you that one basic thing why we would want to actually scale to multiple shards is because you are going to have lots of writes, and writes cannot be scaled using master slave. Do you guys realize that? This is how we started, right? Writes cannot be scaled through master slave, and writes is one primary reason why you would want to shard your data across multiple DBs. And now if you have a hot shard in which every write is happening to the same shard, does it really help you in that particular case then? It does not. So that makes us all unhappy. But it did not mean that we did not learn anything new. We learned something which is going to be helpful in a lot of cases. Okay, Narayan, if this was out to you, that's great. You are thinking in the right direction, and I really appreciate that. But does it mean that range key queries are not going to use it at all? That's totally wrong. Range key partitioning is used a lot in cases where it does not create a problem of hot shards. Does it make sense to everybody? Let's assume that you have a Facebook kind of example in which you have to query people who start with A, or let's say a Google search kind of example. Do you think that all the writes that you will be doing will be going only to one shard? No, because let's say somebody is writing a query that who is the Prime Minister of India. The answer is Narendra Modi. Somebody is writing Narendra Modi. Somebody is writing, let's say, India. Somebody is typing for interview bit. Somebody is typing for their own name, right? You see that the queries that you have are distributed, and there is no problem of hot shard. Does that make sense to everybody in the class? Uze, do you want me to repeat the hot shard again? Hot shard basically means that if you are writing, if the queries that you're doing end up at the same shard most of the times, then that shard becomes a hot shard. And in the case of the sensor example, if you are actually storing data based on dates, and you would realize that all the data that is coming to you would be coming for today's date only, and then it becomes a hot shard that you will be actually writing the queries only to one shard and not to anybody else. And at the very beginning, we discussed that there are two goals here. One goal is that the data should be stored as equally partitioned as possible, and the second goal was that your query should be as equally partitioned as possible. Does that make sense to everybody? Do you guys want me to end the class here? We discussed the problem of hot shards. We now want to discuss more approaches, but that would again take 30 minutes maybe. Do you want me to do that in the next class? Are you guys fine with that? Okay. If there are more people who want to do it right away, I am totally fine with doing it. I don't have any issue. We will all time based create hot shards. Okay, let's have a poll. Okay. So Neeraj is asking, will all time based data create hot shards? Right. So Neeraj, if you have a range key partitioning, point one, everyone please understand. If you have the range key partition, point one. Point two, if you partition based on date. And point three, if you are getting a data which is only for today's date, then yes, you will have a problem of hot shards. Does that make sense? But just because you are sharding based on time, that does not necessarily create a hot shard problem. Just because you have data based on time, that does not necessarily create a hot shard problem. Just because you are using a range key as a partitioning strategy, that does not make it a hot shard problem. Does that make sense to you, Neeraj? No single thing creates a hot shard. So whenever a problem comes to you, try to ask these questions to yourself. There is no ऐसा कोई कुंजी नहीं है कि ये rule book है. Just try to ask the questions yourself and you will figure out the answer yourself because you understand the concept conceptually. Is that right with everybody? Folks, are you understanding the concepts conceptually? We are not rote learning anything here, right? We understand everything now conceptually. Now anybody can ask, you can be very very confident and say कि भाई पूछ लो यार कुछ भी, ठीक है, कुछ भी पूछ लो मुझसे डीबी के बारे में, मैं बता दूंगा, ठीक है. And let's just maybe wait for 1-2 more classes and maybe let's wait for some remedial class on DBMS and then you can be very happy and say कि भाई कुछ भी पूछो यार DB के बारे में, I can have a sane discussion on it, ठीक है. Now let's have a poll. The poll would be asking you, do you want me to take another 30-40 minutes to end it or do you want me to take it in the next class? So let me just add that poll. Cool. So here's the poll in front of you, folks. So please just vote very quickly. अबे यार टेबल से कुछ चुभ गया लगता है मेरे को. Right. So okay, 8 people are still to vote, and let me tell you, those 8 people can decide the outcome. So if you have not voted, you have the keys of success in your hands. Cool. So there are 7 people remaining. Would they want to? Okay. Even if they vote the other way, nothing changes now. So okay, let me end the poll. So this is what the poll results show. 16 of you, 70% of you say that no, we are too tired, may miss out on some concepts. Abhi nahi. 30% of you say nahi karo, aaram se, koi dikkat nahi hai. So it means we will have to end the lecture here. 70-30 is a big win for the folks who were on the no side. That's great. The no's have it, and we can end the lecture here. Have you guys ever seen the Lok Sabha proceedings? Have you guys seen how votings happen there? So have you seen ayes have it, no's have it, no's have it? So just no's have it. Cool. Cool. Yeah. Cool. On to something in backend. Should I learn Spring? Okay. Okay. So Nitesh, that's something that's totally your choice. Based on what I know, based on the companies that I see, Spring would be more in demand. So if you want to learn Spring, I would be happy to suggest that you learn Spring. But even if you want to learn Node.js, that's totally fine. Okay, Nitesh? Cool. Okay. Thanks a lot, everybody. I hope you guys enjoyed the class, and sorry for my bad jokes if those jokes hurt you. And yeah, let's hope to see you again in the next class. And just one request to everybody that please revise the lectures. If you do not revise them, then you may actually forget these things. And if you forget these things, then all of this goes for a waste, right? So please revise the lectures. Do not wait for a time to come in the future where you're going to revise it, or do not think that whenever you're going to give for interviews, you are just going to revise it then. Do revise these lectures before giving interviews, but make sure that you revise it right now as well. Because if you revise it right now, the things are going to stay with you for a longer time. Does that make sense? Because these high level design classes are such that there is no given structure to the classes, right? It's just a discussion class. It's more important to revise these classes much more than revising a DS Algo class, right? Because these are discussion classes. I am telling you some things that I know. you guys are understanding it. If you revise it, maybe let's say revisit it 2 times at a 2 times the speed, 3 times the speed, then you are going to internalize it and not forget it for a long time. Okay, so do it. Okay, and one more thing, so I'm not very sure if I'm going to take your classes the next week. I may have to take the classes for some different batch. So we may, and as we discussed in the last class, so you guys are also, you guys also wanted to discuss some data structures and algorithms. So maybe we are going to have some DS algo classes the next week. I may choose to take a class on Monday because I wanted to cover some more interesting things. But if I do not take a class on Monday, and from Monday, if you have DS algo classes, attend those classes properly. I will be back in a week or so. Okay. So whatever is pending, we will be discussing that once we are back. Does that make sense to everybody? But there is a good probability that I may be taking the class on Monday, but nothing changes. Even if I do not take the class on Monday, that's totally fine. I will be back the next week. But make sure that you guys revise it. Can we have a class and contest questions as well next week? Okay, Deepika. Point noted. I will do it. Okay. If for example I forget it, you can just drop me an email or ping me on Flock, and I will schedule a class for you guys for contest discussion. Okay. Nitesh says, okay, Nitesh, I cannot promise you that, but do not worry about it. Okay. You will be having good classes. That's what I can promise. Cool. Thanks a lot, everybody. I hope you guys enjoyed, and do not forget me in the next week. It's not as if I'm not going to come back. Maybe I will be there back with you after a week or maybe a couple of weeks. Cool. Good night, folks. Good night, everybody. Stay safe and stay happy. See you again in the next class whenever we meet. Okay, bye. Thanks a lot, Sankalp. Thanks a lot. That really means a lot to me. Thank you. Good night. Goodbye.